Hey everybody, we have another fun-filled day of finding factors of a polynomial. Now, so far, the only way that I taught you to find a factor is by using a GCF. So that was yesterday, using GCF. So the good news is we're still going to do that. The good or the bad news, or whatever, we're going to take that another step further. So today we're going to learn how to find, once my pen decides to work, just joking. Maybe. Huh. Look at that, not want to work at all. Okay, how to find more factors of a polynomial. So main rule, just don't get frustrated, okay? So you remember how we used to take two binomials and put them together? And we would, do the first times the first, yada, yada, yada. And we end up with a polynomial down here. Well, today you're going to start with a polynomial and we'll end up in what we call a factored form. So let's reverse that process. Today, the easier type will look something like this, not too many numbers, not too many x's, and it will become this. And then a little more difficult, we'll have a GCF, and it'll end up being this. So please realize that while there are none in the notes today, polynomials and that cannot be factored. They are called prime. So if you can only take out a 1 and there's nothing that works, it's called prime. Now, I will happily let you look at all of these steps, okay? You are going to be given a polynomial. You are going to find that polynomial's GCF, and you're going to divide that GCF out. Then you're going to identify what A is, the number of x squared, what B is, the number in front of x, and what C is, the constant in the back. Then you're going to take that A and C and you're going to multiply them and put B on this side. Then you're going to find two magic numbers that multiply to that -6 and that add to that +5. Those magic numbers go correspondingly diagonal from each other, and the original after the GCF term and the last term go there and there. Then you're going to find GCFs up and down and left and right, and then you'll be all done. You state your factors. All right, that was a lot. Clearly that was not well explained enough for you to be able just to jump into it. So let's take a look at number 1. If you follow these steps, I promise you, you won't go wrong. Step number 1 is always identify what the GCF is. In this case, single item can be divided by a 3, not by an x, because the 30 does not have an x, just by a 3. If I divide every item by 3, that'll give me 1x squared. That'll give me 7x and 10. Step 2, you're going to identify what we call A, B, and C. A is the number in front of x squared. B is the linear coefficient, the number in front of x. C is the constant in the back. Step 3, now that you've identified A, B, and C, you're going to make yourself a little chart. And inside that chart, you're going to do A times C on the left and identify B on the right. So A times C is 1 times 10, and that came from here and here, which is just a big old 10. And B is 7, and that came from here. Next, you have to find two magic numbers that are going to multiply to 10. So they have to multiply to this 10, and they have to add to 7. Now maybe some of you are like, oh, I got it, it's 5 and 2. Well, good for you. You're probably faster than most if you were able to get it that fast. However, the process that works is this. Some kids are simply not as well versed as others in their multiplication table, and that's okay. So I make everybody learn by doing this. Count up 1 through 5. Now, if you watch the screen and you listen to my scraggly voice here, listen, please, carefully, and watch. 10 divided by 1 makes 10. If you add those, you get 11. Oop, where did my 7 go? I'm sorry. You need something that adds to 7. These factors of 10 are not your solutions, even though they multiplied to 10. Watch again. 10 divided by 2 equals 5. 2 plus 5 does make 7. We have found your magic factors. Why are those your magic factors? Because 2 times 5 will multiply to 10, and 2 plus 5 will add to 7. 2 and 5 are your magic numbers, your magic factors. Once you find them, you don't go on anymore. Step 4, you make a box. This box will have 4 compartments to it. Inside compartment number 1, I will color code it in brown. You put the first term after your GCF. So look where I'm at. You put that 1x squared right here. So after you take out your GCF, you put your quadratic term there. The next one I will highlight in lime green. The bottom right, you will put this positive 10. Again, the light green indicates where I got that from. Now, in this burgundy color, you will put this 2 and this 5 here and here. They need this variable, in this case, x and x. Those burgundy items came from there and there. Yes, you may switch those burgundy items. You could have put the 5 in the bottom left. Now we're going to practice your GCF skills. What is the GCF? Make it smaller. What is the GCF of 1x squared and x? A 1 and an x. So we worked our way down. What is the GCF of 5x and 10? 5. When you work your way from the top to the bottom, you take your top sign with each one. If you've done everything right, the 1x should, that's my dog, should always be positive. That's my cat. Now we go left to right. Boom, boom. What is the GCF of 1x squared and 5x? 1 and x. What's the GCF of 2x and 10? Positive 2. It is now time for us to write our final answer. So what are the factors of that original polynomial? Great question. Well, the first factor was our GCF of 3. Our second factor is either one of these 2 items that I am currently going to highlight in purple. Sorry about my animals. So either 1x plus 5 can go first, or 1x plus 2. Please realize that in algebra, we do not write coefficients of 1s. So I have 3 factors. I have a 3, an x plus 5, and an x plus 2. I need to get my dog because she's eating the cat. Daisy, this is so embarrassing. Okay. I guess the dog doesn't know that I'm teaching math. You can see why there's only 6 examples. Step 1. We need to find a GCF. The GCF in this problem is a 2. I apologize. No, it's not, because 2 does not go into 5. The GCF is a 1. And do they all have an X? No, they don't. But they do all have a single Y. Please divide everything by a 1 and a Y. When I divide this item by a 1 and by a Y, I am left with 2x squared and the Y is gone. When I divide this by a 1 and by a Y, I am left with a 5 and an X. When I divide this item by a 1 and a Y, I am left with a negative 12. So everything gets divided by 1, and everything loses a Y. Step next. Step 2. You will identify what A, B, and C are. A is 2. B is negative 5. And C is negative 12. Now my husband's home. Number 3. But you guys didn't want to learn, did you? You will make this fun-filled chart. You will have to put A dot C here and B here. That's 2 times negative 12, which is negative 24, and the value of B is negative 5. You will then count up and hope that it's in these 5 numbers. If not, you will need to increase. Now I will do negative 24 divided by 1 is negative 24. Add those, you get negative 25. Excuse me. I was going too fast in my head. Add those and you get negative 23. That is not the negative 5 that I needed. Negative 24 divided by 2 is negative 12. Add those and you'll get negative 10. That is not the negative 5 that I need. Negative 24 divided by 3 is negative 8. Add those. That is a negative 5, which is exactly what I need. 3 and negative 8 are my magic factors. It's now time to move to the box. Try to recall from the last problem where we pulled everything from. So we got the top left of the box from step 1, this right here. So 2x squared. We got the bottom right of the box from right here, the C value of negative 12. We got the catty corner boxes here and here from our magic factors of 3 and negative 8, and then those could be switched. Whatever variable is right here, which is simply x, goes here and here. Notice the 3 and the negative 8 excuse me, replace the negative 5x. Then I asked you to find GCFs here and here. Top to bottom, the GCF of the first blue line is a 1 and an x because only 1 goes in them and they each have an x. The GCF of the second blue line is a 4, but you will bring down a negative 4 because the top is a negative. Left to right, the GCF here is a 2 and an x. 2 goes into 2 and 8, and they each have an x. The GCF here is a 3. It is a positive 3 because you pull from the left. Step 5 is where we state our final answers. All the factors of our original polynomial. So we start with whatever our GCF was, which was a 1y. Then we move into these items here, and you can put the 1x minus 4 first, or the 2x plus 3, it doesn't matter. And that's because multiplication is commutative. Get rid of the ones that are not needed. Now it's time to do number 3. Step 1. Let's see what color is step 1, green. My husband's here, maybe he'll want to come factor with us.
Did you say factor?
I did. The GCF is the number and the variable that's common to all of them. In this case, everything divides by 2. Everything also has a single x at least. Divide this by 2 and take away an x. You'll be left with 6x squared. Divide this by 2 and take away an x. You'll be left with 1 and x. Divide this by 2 and take away x. You'll be left with a single 1. Step 2 is blue. Ooh, step 2 is blue, that rhymes. Identify A as 6, B as 1, and C as -1. Step 3. Make a chart. On the left, you have to put A times C, and on the right, you have to put B. A times C is 6 times -1, which is -6, and B is 1. So that came from there, there, and there. If you don't know two numbers that multiply to -6 that add to 1 right away, you need to go through that process. So I would do 1, 2, 3, 4, 5, and hope that it's in there. -6 divided by 1 is -6. Add those together and you get -5, which is not what you want. -6 divided by 2 is -3. Add those together and you get -1. That is also not what you want. However, there is a rule that if you get the number you want, for example, I wanted a 1, but you get the wrong sign, there's a cute little trick where you just change, and change all 3 of those signs, and that'll work. If you really want to test it out, which I'm sure you do, -2 times 3 is -6, and if you add them, you get the +1 you want. Your magic factors are -2 and +3. Now that we found your magic factors, it's time to go to the box. I'm going to keep the same color coding. I believe I used brown for the top left and lime green for the bottom right. Then catty corners, I think I used burgundy and burgundy. All right, so the brown. The brown comes from step 2, and it's right here. It's the 6x squared. The lime green also comes from step 2, and it's right here. The catty corner boxes come from, I'll highlight it in burgundy, here and here. So -2 and 3, and they keep this variable right here which in this case is an x. Now we find those GCFs that we love so much. What is the GCF of 6x squared and 2x? A 2 and an x. What is the GCF of 3x and negative 1? So what goes into 3 and into 1? Just a 1. When you work your way top to bottom, take the top sign. Left to right. What is the GCF of 6x and 3x? Well, 3 goes into both of them, and x goes into both of them. What is the GCF of 2 and 1? Just a 1. Since we're pulling from the left, take the sign from the left. Step 5. State your final factors of the original polynomial, which were the original 2x, the bottom 2x plus 1, and the other 3x take away 1. There's nothing here that the keystone, you need everything, even those ones, because they're important. So the final factored form is the GCF of 2x, the 2x plus 1, and the 3x minus 1. We've got 3 more to go. Every time I'm trying to speed it up a little. Step 1, find the GCF. The GCF in this particular one is, well, what do they all have in common? I see that they all have a q, at least a q to the first power, and they all also have an r to the first power. So I got to take a q away and an r away, a q away and an r away, a q away and an r away. Please note that they don't all have a coefficient that's common to take out, so it's just variables as your GCF. You're more than welcome to chime in if you want. You don't have to. If you take out a q and r of this, you will get a q to the second power, and the r's will go away. If you take a q out of this, you'll be left with a q to the first, and these r's will go away. If you take out a q, these ones go all the way away, as do the r's. So we've taken out the GCF. Step 2. Find A, B, and C. A is the coefficient of the first. B is the coefficient of the linear, like the power of 1. And C is the constant in the back. Step 3. Step 3 is where you make that chart. You put AC here and you put B here. AC is 1 times 24 and B is negative 10. So we have to get two numbers that multiply to 24 and add to negative 10. If you know them right away, good for you. Most students do not. 24 divided by 1 is 24. Adding those together, you get 25, which is definitely not the negative 10 that we need. 24 divided by 2 is positive 12. Adding together is 14, which again is not the negative 10 that we need. 24 divided by 3 is 8. Adding together is 11, which again is not the negative 10 that we need. 24 divided by 4 is 6. Adding together is 10, which is close to our negative 10. Remember I told you in a previous problem that if you get the right number, 10, but the wrong sign, you change. Negative 4 and negative 6 are what we call our magic factors. Step 4, draw a box.
You're very good at this.
Thank you.
I thought math didn't have magic in it, though.
It does.
Interesting.
Math is magic. Okay. I hope somebody's listening to this. The top left of the box is this item here. So 1q and squared. The bottom left of the, the bottom right of the box is this positive 24. The other corners are from our magic factors of -4 and -6. And they get the variable up here, which is q to the first. That's a cat. And those were the burgundy ones. Now it's time to find those GCFs. What is the GCF of 1q squared and -6q?
I'm going to go with Q.
Yep, just a q. If they wanted to have a coefficient, they could say 1. What is the GCF of -4q and 24?
I'm going to say 4.
Good.
Wow.
And when you go from the top to the bottom, you take the top sign.
Oh, tricky.
What is the GCF of 1q squared and -4q?
Q.
And if they want a coefficient, they like seeing that, it would be a 1.
Mm-hmm, mm-hmm.
What is the GCF of -6q and 24?
I'm going to go with -6.
That's
We
right.
started left to right. We took the sign of the left.
That's right.
Wow. See, I'm a quick learner.
Step 5. It helps that you help me write my curriculum. Step 5, we finished by writing all the factors of the original polynomial. So we start with our GCF, which was a q to the first and an r to the first. And then we write the double binomials that we got from step 4. So you can do 1q minus 4 first, or 1q minus 6 first. Please remember, the keystones will not have the exponents of 1s, and they won't have the coefficients of 1s.
Ooh.
2 more. Each of these takes 5 minutes. It's going to be a long class tomorrow.
Nah.
They just can't
Time
get,
flies
if they
when
don't
you're having
get,
fun.
this isn't fun for them. Okay, GCF. What number, not a trick, maybe just hard. What number goes into 48 and 27?
Ooh, my. Ooh, yeah.
Well, think about 27. What goes
Yeah.
into 27?
9 and 3.
9, 3, and 1.
Mm-hmm.
So what also goes into 48?
Well,
Not
3.
27.
No.
And not
9. 3.
So it's a 3. Do they both have an M or an N?
They have an N.
Then that would be our GCF. So we're going to divide by 3 and take away an N. Divide by 3, take away an N. Okay. Divide by 3, what do we get?
I'm going to go with 16.
Take away an N, what do we have left?
M squared.
Divide by 3, what do we have left?
Be a 9er.
And what do we know about those N's?
Gone.
Good. And it's like n to the 0 power, which we don't write. I don't like how smushed that is. Step next, 2. A is the number in front of the squared term.
Okay.
Which
so
is?
16.
Careful. B is the number in front of the m to the first.
I'm gonna, wait, hold on. 1.
0.
There's not
We
the
have
first.
no m to the first, so B is 0.
Okay. 0 times, I think, 0. So yeah.
C is the number in the back.
-9.
The constant without a variable. Okay, now for our chart. The chart puts AC here and B here. AC is what?
16 times -9.
Oh dear.
Oh, that's a big number.
144, right? Negative 144.
Yeah, I think so.
And B is?
0.
Okay. I'm just going to save time. I'm going to tell
Oh,
you.
I know it.
Oh my gosh, hold on. But you have to understand not everybody has the brain that you have.
Well, I just got really excited for a second.
Well, that's good. It's very hard for kids to make it through this one.
Well,
Now, if you
that's a lot of
divide,
numbers.
yep. If you divide by 1, let's just do a couple to prove that it's not those. If you divide by 1, you get negative 144, and if you add, you get negative 143, which is certainly not 0.
No, not 0.
If you divide by 2, you get negative 72, which if you add is negative 70, which is certainly not 0.
Nope.
If you divide by 3, don't you get a decimal? No, you get 48. Okay, so if you divide by 3, you get negative 48. And if you add, you get negative 45. But who cares because it's not 0. If you divide by 4, it doesn't work. If you divide by 5, there's your decimal. Let me get this. So I'm going to do negative 144 divided by 5, decimal. Negative 144 divided by 6, 24. So if you add those, what do you get? So this one's no good. I know it's not 4. What do you add? Add those to be negative 18.
Negative 18.
That's not it. Negative 144 divided by 7. Negative 144 divided by 8. Okay, so maybe. So no, because you can't get a decimal. So negative 18, negative 10. Getting closer. Negative 144 divided by 9 is negative 16, which is negative 7, but not it. Negative 144 divided by 10. Decimal. Negative 144 divided by 11. Decimal. Negative 144 divided by 12. Negative 12. And what do you get if you add those?
0.
Was that going to be your guess originally?
It was.
My hero.
The only reason I just knew 12 times 12 was 144.
That's good. And that will serve them very well if they can too think about perfect squares that way. They'll learn that as a shortcut, but this is their first day, so they might not have that done. Okay, let me get my brown highlighter. This top left box comes from step 2.
Why'd you pick that brown?
Because.
It's
So I'm going to
color.
put 16m squared here. And this green, hey, comes from right here, comes from C. So negative 9. No one's watching this. And
You
then
don't know that?
I do.
No.
Then my magic numbers come from here. Darn it, sauce. 12 and negative 12. And they need the variable of, well, half of that. So m to the first. So 12m, negative 12m, and then those could be switched. GCF time. What's the GCF of 16m squared and 12m?
Is that 4m?
Mm-hmm. What's the GCF of 12 and 9?
3.
And because top to bottom,
Oh, that's a negative.
now GCF this way, 16 and 12 again,
That's what, 4m?
and they both have an M. And GCF here, 12 and 9,
3.
and they don't both have an M. And that's a positive 12, so positive 3. Our final factored form, what do you think the dog's doing? Is our GCF at the beginning of 3 and n, and then 4m take away 3, and 4m add 3. One more. Number 6. GCF.
This is better than Mario Kart.
I highly disagree. GCF. I told them today, though, that math was like a video game. The more you practice it, the better you get.
That's a very true statement.
I think so. I mean, so it's really just like playing games all day in
Yeah.
my room. All right. What goes into 16? Whoa, this is... Okay. What goes in to all of those coefficients?
Ooh. 2?
Mm-hmm. So let's take that 2 out. Divide this by... And they don't all have an x. So what is that going to be?
8x cubed
And then this one.
minus 12x squared
And then that one.
plus 2x minus 3.
Okay. Now something special to note about this one. Special. Do you notice that this has 4 terms? Can you notice that has 4 terms?
I see that. Yeah.
Okay. They should be really happy when that happens. You know why?
Why?
They go straight into the box. They don't have to do step 2 or step 3, which are some of the most miserable steps. Well, not step 2, but step 3 is miserable. So we go straight into the box. Do you want to take a guess as to what goes here?
Oh, you put me on the spot now. I'm going to get 8x cubed.
Do you want to take a guess as to what goes here?
Is that negative 12x squared? Negative 3.
That's right. So the first goes on the first, the last goes on the first.
Okay.
Would you like to take a guess as to what goes here?
I'm guessing you need to figure it out. Or no? That whole thing?
Just those 2. It's like it's already done for you.
Wow.
It's just like that. Isn't that kind of cool?
Beautiful.
So they get to skip all the steps there. All right. I need a GCF here.
2x.
I need a GCF here.
3.
Minus or plus?
Minus.
Because of the top.
Mm-hmm.
I need a GCF here.
4x squared.
4 goes into both of them, and they both, the smallest exponent is x squared. I need a GCF here.
1.
Plus or minus?
Plus.
Okay. Now, we do need to do our final step of writing all of our factors of our original polynomial. So we start with the GCF at the beginning. Then we come back with 2x take away 3 and 4x squared plus 1. Do you want to know something? Say yes.
Yes.
So there's a different way to factor called grouping that personally I actually like, but kids tend to hate. But the grouping works really well for 4 terms. Box looks like it works really well because it was like you got to skip it, but you have to check it. So tell me, what is that times that?
That is 8x cubed.
So we can see, sure enough, we got this 8x cubed. What is this times this?
2x.
So you can see we have that. What is this times this?
Negative 12x squared.
What's this times this?
Negative 3.
If that didn't work, we would have to say that it's not factorable.
And do you want to know something?
Nope. I'm done.
When you said final step, it made me think of the song Final Countdown. Final Countdown.
I'm going to tell them goodbye now.
Okay.